Hey guys, welcome to Unit 4, which is about complex numbers. Our first lesson, we're going to continue from where we left off in Unit 3 with the quadratic formula. So, Unit 4.1 is about the discriminant of a quadratic. By the end of this lesson, your goal is that students will be able to use the discriminant to determine what type of number the roots of a quadratic turned out to be. So, as we talked about earlier, we talked about the quadratic formula, which is x is equal to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Now, what is this a and b and c? Remember, that came from your quadratic formula, which is ax squared plus bx plus c. Now, the part that's under the radical, and if I highlight this piece under the radical, just what's under the radical, that is known as your discriminant. So the discriminant can be used to determine what type of number the roots are. So are the roots rational? Are they rational? Are they imaginary? So what are rational numbers? Just a really quick review. Rational numbers are numbers that can be written in as simple as fractions. So something as 2 over 3 is rational. Something as 0.5 is rational because we know 0.5 is 5 over 10 or 1/2. Irrational numbers are numbers that can be written in decimal but not in a fraction. So example of this can be pi. We know pi is 3.142 blah 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 blah. Another example is square root of 2, or any number that's not perfect square. Square root of 2, if you check it on a calculator, is 1.414213, and it keeps going on and on and on. And the last thing, which is our focus for this unit, is imaginary numbers, which are numbers that are in this form, a plus bi. What does that mean? A and b are just real numbers, any numbers on the number line, and the I comes from the square root of a -1. So let's see how this works. Example 1. It says, for each of the following quadratic, calculate the discriminant, its root, and state the number and nature, whether they're rational, irrational, or imaginary. So the first thing I want to do is use this. And as always, what do I need to do when I have a quadratic? I identify my A, my B, and my C. Again, these are coming from this quadratic. So my A is 1, my B is 3, and my C is -10. So I want to go ahead and put that in my discriminant, which is the piece that's under. So this is actually equal to b squared, which is 3 squared minus 4 times 1 times -10. So if I was to put this in the calculator by itself, you can get an answer, but let's work it out. 3 squared I know is 9. Take away what's 4 times 1 is 4. 4 times -10 is -40. I put 9, take away -40 is 49. So my roots, my discriminant is 49. What I want to do now is find the roots. So remember your quadratic formula, you already now have everything here. Minus b plus or minus the square root of b squared minus 4ac all over 2a. So what we want to do now is use this to find the roots. So again, I'm just going to put the formula here. Minus b plus or minus b squared minus 4ac over 2a. So my root, minus b, so this now, let's separate this out. Minus 3 plus or minus the square root. We just calculated this. B squared minus 4ac is 49. Everything over 2 times 1. Now remember, this is minus 3 plus or minus 7 over 2. Now what can we do? Remember, this is where I branch these off. Minus 3 plus 7 over 2, or minus 3 minus 7 over 2. And if I was to simplify this, I will get 4 over 2, which is 2, as my final answer. And here I will get negative 10 over 2, which is negative 5. So my roots are 2 and negative 5. The last part of the question say, what's the number and nature? So the number and nature, it means, what are these numbers? These numbers refer to your roots. The nature refers to, are they rational? Are they irrational? Are they complex? 49 is a rational. How do I know that? It can be written as a fraction, 49 over 1. Bam, that's it. And what does the number? The number means it's 2 and negative 2, and those are two unequal numbers, and then the nature is that they are rational. No, rational roots. So the rational roots, these can be written as a fraction, 2 over 1, or 4, like you can see right here, 4 over 2, negative 10 over 2. They're unequal, they're 2 and negative 5. So let's say this was 2 and that was 2, they would have been 2 equal. Let's see, we have some cases. So for case 2, it says the discriminant is not a perfect square. In case 1, which is at the bottom here, we saw that the discriminant is a perfect square, meaning the square root of 49 was giving me a perfect number, which is 7. So again, I want to do this here. My discriminant is equal to, what's my A, B, C here? My A is 1, my B is negative 6, my C is 7. So this becomes negative 6 squared minus 4, 1 times 7. This becomes 36, take away 7 fours, 28. 36 take away 28 is 8. So my discriminant is 8. So now let's find the roots. Remember, use your quadratic formula. I know my root is x is equal to minus b plus or minus the square root of 8, everything over 2 over 1. This becomes 6 plus or minus the square root of 8 over 2. So remember what we said, this always is branched out. So I can make this x equals to 6 minus the square root of 8 over 2, or 6 plus the square root of 8 over 2. Now, this one is when it's not a perfect square. So the square root of 8, I know it's going to give me numbers that go on and on and on and on and on. So again, the nature and number of these are going to be 2 unequal numbers, because again, these two here are not equal, and they're going to be irrational roots. If you were to put this in the calculator, let's see what we'll get. Let me get my calculator. Go get yours. I'm going to wait. So I got my calculator. Let's enter this. Enter fraction, control division, and I have 6 minus the square root of 8, and in the denominator it is 2. Notice this number, it will go on forever and ever. If you hit the up arrow that's highlighted in blue and hit enter, notice it goes on, and this can still keep going. So that's what it means when it's an irrational number. So back to our question, it says that these are going to be two irrational numbers. There are 2 more cases we need to look at. So case 3 says when the discriminant is equal to 0, what happens? So in this case, you know the discriminant is going to equal to 0, but nonetheless, let's do this. A is 1, B is negative 10, and C is 25. My discriminant is equal to negative 10 squared minus 4 times 1 times 25. This is minus just to be Careful. 10 squared is 100. Minus 4 times 1 is 4. 4 times 25 is 100. 100 take away 100 is 0. Now what about my roots? So let's make a pathway here. Again, my quadratic formula, you have to know this. X is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. This is going to be on the region, so you don't have to memorize it. So we have here the roots is going to be x is equal to minus b, which is minus negative 10, plus or minus the square root of 0 over 2a is 1. This becomes 10 plus or minus the square root of 0 over 2. Now how can I split this up? Remember, you'll have to answer. First of all, what is the square root of 0? Get your calculator and check it. So this becomes x is equal to 10 plus or minus 0 over 2. And how do I split this up? So I'm just going to come to the side here. This becomes 10 plus 0 over 2, which is 5, or 10 minus 0, which is over 2, which is also 5. So those are my roots. Now the last part says the nature and the number. So we know the number here are going to be 2 equal. And then what kind of number are they? Are they rational? Are they rational, or are they complex, imaginary numbers? These are rational numbers, correct. They not in a decimal form that goes on and on and on. They're rational roots. They're not complex, meaning nothing has an I inside, and they're 2 equal, 5 and 5. So 2 equal rational roots. The last case that we have is case 4. The discriminant is less than 0. So in this example, my a is 1, b is negative 8, oops, that's an 8, and c is 20. So what's my discriminant? My discriminant is b, which is negative 8 squared, minus 4 times 1 times 20. These numbers are coming from up here. Negative 8 squared is 64, take away 4 times 1 is 4, 4 times 20 is 80. 64 take away 80 is negative 16. So my discriminant is negative 16. Now if I was to go ahead now and do the roots, what would I do? So my roots, x is equal to minus b plus or minus the square root of negative 16 over 2 times 1. If you were to put this, work this out, I'm going to get positive 8 plus or minus the square root of negative 16 over 2. This is known, and let's make a note, this is known as a complex number because of this right here. Why? And I'm going to, not the crayon, I'm going to highlight it in here. This goes with the complex. That's what makes it a complex number. So we're going to talk about how do we later simplify this. For now, you just need to know anything that has a negative under the square root. That means that automatically you will know that the nature of this will be an imaginary root. Now, are they going to be equal or unequal? When we find this out, we're going to work this out. It's going to be 2 unequal. Remember, they're only equal in our third case when the discriminant is equal to 0. Because if I was to break this out, just to show you guys why, if I was to break this out, I would have gotten 8 plus square root of negative 16 over 2, Or I would have gotten 8 minus the square root of negative 16 over 2. So it would have been 2. This is what makes it unequal. So what I want us to do is try some together to see how this works and how it comes on your Regents exam. Let's try some. By only using the discriminant, determine the nature and number of the roots of the following. Alrighty, so our first example. The first thing you always have to do, guys, is what's my A, what's my B, what's my C? So my A is 2, my B is 7, and my C is negative 4. And the discriminant I'm going to write up here is equal to, basically it's what's under your radical sign, which is B squared minus 4AC. So it becomes 7 squared minus 4 times 2 times negative 4. This becomes 49 take away negative 32. This becomes 81. So my discriminant is 81. I know if I take the square root of 81, I will get 9. So that should automatically tell me I'm dealing with a case 1. What do I mean by case 1? If you go back to the first page, it says the first case is when the discriminant, whenever the discriminant is a perfect square, I know it will be 2 unequal rational roots. When the discriminant is not a perfect square, it's going to be 2 unequal irrational roots. When the discriminant is 0, we saw that it was going to be 2 equal rational roots. And then the last case was when it's less than 0, it's 2 unequal imaginary roots. So this is from the first case, and I know that the discriminant is going to be 2 unequal rational roots. Oh, I forgot the AL. Rational roots. That's all we have to do, and these are normally multiple choice. Alrighty, B again, my A is 1, not negative 1, Miss Samaru. My A is 1, my B is negative 8, my C is 25. So what's my discriminant? My discriminant is negative 8 squared minus 4, 1, and 25. This becomes 64. Take away 100, which is negative 36. So when this is a case, the last case, 4. So when it is less than 0, it becomes 2 unequal. What is it? Imaginary, because it's a negative, it's less than 0. Imaginary roots. That's it. C and D before we go anywhere else. So A is 4, B is 4, C is 1. So my discriminant is 4 squared minus 4 times 4 times 1. 4 squared is 16, take away 16 is 0. When my discriminant is equal to 0, I know I will have 2. I will have 2 equal rational roots. And let's make a reference. This has to be, we know that this is case 3. Is that correct? Let's check back really quick. Yes, case 3 is when the discriminant is 0. We know this was case 1. This was case 4. So let's try this last one here. D. Okay, so my A is 1, my B is 6, my C is 15. My discriminant becomes 6 6 squared minus 4 times 1, oopsie, 15. 6 squared is 36, take away 4 times 1 is 4, 4 times 15 is 60. This will be equal to negative 24. So here again I have a case 4 when it's less than 0. So because it's less than 0, I know that I will have 2 unequal imaginary roots. Alrighty, so that's how it comes on the regions, okay? So you have to find the discriminant. If it's a case 1, meaning the discriminant is a perfect square, it will have 2 unequal rational roots. If the discriminant is less than 0, meaning anything that's negative, it will be 2 unequal imaginary roots. When it's 0, that's when you'll have 2 equal rational roots, and the one that we didn't see as yet, but we saw in the example, is case 2 when it's not a perfect square. When it's not a perfect square, it will be 2 unequal rational. Example 3, say consider the quadratic function whose equation is y equals x squared minus 4x plus 4. Determine the number of x-intercept of this quadratic from the value of its discriminant. Then sketch the graph on the axis given. We say the parabola is tangent to the axis, the x-axis, but let's see why. So I want to know the discriminant. From this here, my a is what? My a is 1, b is negative 4, and c is positive 4. So let's find our discriminant. Discriminant is equal to b squared minus 4ac. My b is negative 4 squared minus 4 times 1 times 4. This becomes 16 minus 16, which is 0. Again, when there is a 0, when your discriminant is 0, it means that there are two equal, because your discriminant is 0. So this becomes 2 equal rational roots. Now, how would this look? Get your calculator and let's graph this together. Your calculator, you want to go to home, and then I want to go to graph. If you have anything in here that you see graph, go to document and the letter B and change it. So I want to graph, what is it? X squared minus 4x plus 4. Is that my equation really quick? Minus 4x plus 4. Perfect. You hit enter. You will see that if I go to menu, trace, graph trace, and I go up and down, minimum at 2, 0. So all this is telling you is that this graph, when the discriminant is equal to 0, that the graph will touch the x-axis one time. So this is what you're sketching, a beautiful graph here. So the last thing before we move on to the last example that I want to show you is how to get these. You notice I put some numbers here at the end. How do you get your graph to look like this? So here you go to menu, and I want to go to window settings. My x minimum is negative 2, and I want to match these numbers. Here it's 6, this is 6, this is negative 2, and then what's my y maximum? We said was going to be 10. So make sure your window is set this way and you hit OK, and that's the graph, the same exact thing, window size that I have here. So the last example before we move on is, which of the following parabola has 2 unequal rational intercepts? So we know that they have any quadratic will have 2 unequal rational intercept when the discriminant is a perfect square. So all we gotta do is test these out. So let's do choice 1. Choice 1, my A is 1, my B is negative 2, and my C is negative 1. So my discriminant is equal to negative 2 squared minus 4 times 1 times negative 1. This becomes 4 take away negative 4. This is 8. 8 is not a perfect square, so choice 1 is out. Choice 2. A is equal to 1, B is equal to 2, C is equal to negative 15. My discriminant is D is equal to 2 squared minus 4 times 1 times negative 15. 4 take away negative 60. This is equal to 64. Now is 64 a perfect square? Yes, it is. So my answer is choice number 2. We don't even care about these because we know that the square root of 64 is 8. Whoa, that doesn't look like an 8, but that's an 8. Alrighty guys, you know what to do. Go ahead and practice those problems and then come get your mastery quiz. Bye!